So last time we talked about the line of best fit. Now we're looking at a similar type of line, but it's a little more complicated, which is why we actually use the calculator to figure it out for us, which is great. So it's called the least squares regression line. Consider the set of points alongside. So in other words, these points over here, this one. For any line we draw to model the linear relationship of the increase in the points, we can find the vertical distance, d1, d2, d3, so forth. So they're talking about, look up, they're talking about this distance here. Do you see the green that I'm drawing? This vertical distance here. So it's between the dot, the vertical distance between each red dot and vertically up or down to the line. Does that make sense? Okay. So now we can square each of these distances and find their sum. If the line is a good fit for the data, most of those distances will be small, and so will the sum of their squares. So the smaller it is, so the smaller these are, these green lines, the better the line that we've drawn follows the data. Does that make some sense? So the further away the line is from the data, that's bad. Okay? So what they do is they get each of these distances, square each one of them, and then add up those squares. And so what we want our final amount to be as small as possible. Then we know we've done a good job, which is why it's called the least squares, when the squares are the least value. Does that make sense? So the idea is when we add up all those squares, if we've got a small value, we've done a good job. What is a small value? Well, it's comparative. Okay, but the good news is we don't actually have to do it. The calculator is going to do it for us. So the least squares regression line is the line which makes the sum of all these squares as small as possible. And the calculator will work that out for us. So let's try a question. A researcher recorded data on annual rainfall and number of bushfires for a region in the following table. Wait a minute, girls. The more rainfall we get, what do we expect to happen to the bushfires? Go down? So, if bushfires go up, let me try that again. Rainfall increases and bushfires decrease. What kind of relationship do those two things have? Negative correlation. Does that make sense? Our plot or line should be going downwards from left to right. That's what we're expecting. Does that all make sense? And we'll see if it actually does. And so we also expect R to be negative as well. And let's see if that's what we get. Okay, so there's all the data. Now plot the points on the grid below. Have I included a grid? Good. Now, see this grid with the teeny tiny squares? That's often used in exams, and it's a bit annoying, it's a bit close, but this is quite common. So now what I want you to do, just plot them as points. So girls, generally a point like this is used, but if you did a cross, that's fine too, just make them small. Is it a kind of trend we were expecting? Yeah, because it's downwards. You know, like this point here means there were very few rainfalls, therefore there are lots of bushfires. So it makes sense. Okay, let's go back to the questions. Plot the points and then calculate R. Only way to do that for us is our calculator. Put in rainfall in the first column. Alright, you'd put rainfall in here as in column A, and you put and bushfires in column B. You might use headings. What headings would you use? R and B. If you want to use words, you might even do rain and bush or something like that. Your choice. You technically don't have to do headings in your columns, but sometimes it helps to remember which one's which. So I'll just let everyone do that now. The difference in the previous lessons is once you put your data in, now when you press menu, it'd go to statistics and stat calculations. You choose linear, regression, and I like to choose mx plus b because that's what the type of line we usually do, mx plus b. So choose that. after you choose statistics, and then I think it's stat calculations, and then choose that. So using our calculator, we found R was negative 0.903. So now that we've got that value of R, what would you say is the relationship between the two variables? How would you describe it using words? A negative, strong relationship or correlation, yes. Use technology to find the least squares regression line. The good news is we don't have to do anything else. It's already there for us. So if we could go back, the equation would be of the form y equals mx plus b, because that's the form we chose. Does that all make sense? So girls, go back to your calculator screen. Can you see the value of m? What is it? To three significant figures, please.
Minus 1.148.
148, so what's 15? So we got to get good at that. Plus, okay, so that's y equals, what's your b value? 40.9, beautiful. Now let's draw it actually. So negative 1.15x plus 40.9. So girls, does that, first of all, we haven't been asked to draw it, but what you could do is just sub in a couple values. What values of x can we see on our graph so we can draw it? 20? Sure, let's draw it. With x is 20, and let's sub that in and see what happens. When x is 20, y equals negative 1.15 times 20 plus 40.9. Can someone please find that on the calculator for me? Okay, we got 17.9. So what that means is, girls, we know the point 20, 17.9 lies on our line. So if we want, we can go down here and actually graph that. What did you get for 10? X is 10. 29.4. Okay, so when x is 10, about here. So now, if I draw a nice long straight line with a ruler through those two crosses, that's generally what's done. So now, predict the number of bushfires if we get 30 centimetres of rainfall using the graph and the equation. What do I do using a graph? 30 centimetres on the x-axis, and then go up. So 30 centimetres hits it about there. Oops, I might use red. About here. I got 6 exactly, girls. So, according to our graph, the number of bushfires is 6. Now, how do I use the equation? You've done that. Exactly, just sub it in. So, we're going to sub in 30 into our equation. Y equals negative 1.15 times 30 plus 40.9. Could someone please do that for me? 6.4. So, I guess really anywhere between 6 and 7 is pretty good prediction. Okay, so that's how many bushfires according to the equation. All right, interpolation and extrapolation. What is all that? Consider the data shown below. The highest and lowest data points are called poles. So in other words, do you see this? With this particular data on this graph that's shown here, this first point, and we're talking about really to the right and left, okay? So the first point in this direction is this one here. The furthest point in that direction is this one here. So they're like the two end poles. Everything making sense? So now, as in the previous example, we can use the least squares regression line to estimate values of one variable using values of the other. So in other words, like I can predict something in here by going up to the line and going across, or using the equation. Everyone okay? But if we use values of x that are between these poles, so in here in this green area, according to that diagram, this is called interpolating, because we're choosing values of x that are within the values we were given. Does that make sense? if we choose values of x outside of these poles, either over here or over here, this is called extrapolating, because it's outside the region that we were given. Now, have a think about this. The accuracy of an interpolation depends on how linear the data was, which can be determined by the R correlation. So the closer R is to 1 or -1, the better our interpolation is going to be, the better our estimate is going to be, and the stronger the relationship, and the stronger it follows that one line. Does that make sense? Now, the accuracy of extrapolation also depends on that linear trend, and it depends on the context of the question. Because you know how, like, when we were talking about height and age. For most of your life, they both increase together. But for the later part of your life, so in other words, this end part, it goes in a different pattern. It goes downwards. In other words, at the extremes, we often do different things. Does that make sense? Especially, and in the beginning of your life, you grow really quickly, whereas in the middle, you're a lot slower. Practically stop. So like at the extremes, either at the beginning or at the end, often you won't follow the same trend as in the middle. Does that make some sense? So for those reasons, in fact, interpolating is generally more reliable than extrapolating, because we can kind of assume the trend is followed within the values we were given. But assuming the trend is followed outside the values we were given is a little bit harder. We're assuming a lot. Now, with this in mind, comment on the reliability of your answer to AD on the previous page or on the same page. Was it this one? 8? Yep. So girls, back here, was 30 centimeters of rainfall interpolating or extrapolating? Extrapolating, that's also because 30 is bigger than any of these values here, isn't it? So it's outside the range of values we were given. Therefore, is our prediction very reliable? It's not as reliable. It's not that it's wrong. It may be perfect, but it's not as reliable as the values within the range we were given, or between the values we were given.